We are continuing in section 3.6, where we looked at the graphs of the sine and the cosine functions. And what we will do now is transformations of the sine and the cosine graphs. In our formula packet, this is at the top of the third page. And you can see here, so it is just this part that we will be working on, which summarizes how we handle transformations of the graphs of sine and cosine. If you remember from college algebra, when we have expressions of the form a times f of bx plus h plus k, if you remember, that's what we were doing in our review of college algebra. And also in our formula packet, we saw all of these things over here, transformations of graphs. The A is a vertical scale and a reflection about the x-axis. The B is a horizontal scale and possibly a reflection about the y-axis. The H and the K are horizontal and vertical shifts. Anything that happens to x happens backwards from what you see in the expression. So if you see a quantity added to x, then that will be a left shift. If you see a quantity subtracted from x, that will be a right shift. If you see x doubled in your expression, it will be a scale by 1/2 on your graph. If you see x halved in your expression, it will be a scale by a multiplication, like a multiple of 2. So all of these things are now kind of summarized here so that you can follow one process. There are two types of ways that a function could be given to us. One is the expression with x is not factored, and the other is the expression with x is factored in a way that the coefficient of x inside the parentheses is equal to 1. And that could be true either for the sine or the cosine. The reason we are treating them together is because they have the same domain, the same range, the same midline, the same period. So they have similar ways of getting transformed. If you remember, B is a horizontal scale. Horizontal scale for the graph means that it will change the period of the graph. How often will one cycle be repeated? How long will it be? The new period is whatever is the reciprocal of B. So it will be 2 pi is the original period of the sine and the cosine function divided by B. The negative C or the negative E, notice here that in our formulas they are negative. So if you see a plus there, then your C itself is negative. If you see a minus there, then the C itself is positive. Same thing for E. These are horizontal shifts. They will go in the direction opposite to the sine, you see. You will start either at C divided by B if it's not factored, or at E if B is factored out. A is a vertical scale. In terms of the graph, this indicates the amplitude of your graph, how much your wave will be stretched or shrunk about the midline. So your new amplitude here will be A, the absolute value of A, times 1, because 1 is the original amplitude. And D is the vertical shift. And vertical shift means that your midline will shift. And now you will get a new midline, and that new midline will be at D. Because it was originally y equal to 0, and now it's just going to move D units. Now, when you are graphing a function, the sine or the cosine function, you have to remember how the graph looks like. And the graph looks like, for the sine, we start at 0 and we go up. Well, we start at the midline, I should say. We go up, down, hit the midline again, go down and hit the midline again. So that will be our graph. It could be shift horizontally or vertically. So I don't start at 0. I start at the phase shift. It could be moved vertically. So again, I don't start at y equal to 0. I could start above or below, depending on d. For the cosine function, the graph is different. For the cosine function, you start at the top of the cycle. You go to the midline, to the bottom, to the midline, and come back to the top. And again, you could be shifted horizontally, left or right, depending on the horizontal shift, vertically up or down, depending on the midline. One other thing that could potentially happen is that you will have a reflection. And a reflection means that your sine curve, instead of starting at the midline and going up, it could start at the midline and go down. The cosine curve, instead of starting at the top and going to the bottom and back up, it could start at the bottom and go up and then end at the bottom. This will be if A, which is the vertical scale, is negative. If the number multiplying the sine or the cosine function is negative, then you will be starting at a reflection. So just keep those things in mind. So the key points here is, once you have identified the period, you know how long it will take you to draw one cycle of your function. You need to know the points. The points are called critical points. And in one cycle, there are 5 critical points: the beginning and the end, the middle, and the 2/4 of the period. In the case of the cosine, the beginning, the end, the middle will be the lowest point, and the 2/4, the first and the third quarter, that will be at the midline. So you need those points. Now, those points, depending on whether it's a sine or a cosine function, will have an easier y to identify. Your y will be at the midline, they will be the middles, and plus the amplitude and minus the amplitude to find the highest and lowest points. The question is, how do we find the x-coordinates? And the way we find the x-coordinates is we cut the period in quarters. We start at the horizontal shift, and then we add 1/4, 2/4, 3/4, and 4/4, and we will find the 5 points. The first point is at 0, so horizontal shift plus 0, and then the other points are plus 1/4 of a period, plus another quarter of a period, plus another quarter of a period, and plus the last quarter of a period. So the 5 key points of the cycle of a sine and cosine curve correspond to the original angles of the 5 critical allocations: the 0, the pi halves, the pi, the 3 pi halves, and the 2 pi, which is the quarters of the original period. When you are graphing transformations, these points have shifted and scaled horizontally. So they are located at the horizontal shift plus 1/4 of a period, horizontal shift plus another quarter of a period, horizontal shift plus a third quarter of a period, and horizontal shift plus the 4th quarter of a period, which is the whole period. And then the y depends on whether you are graphing a sine or a cosine. So sometimes we start at the midline, sometimes we don't start at the midline. So the y coordinates depend on the curve, cosine or sine, the amplitude, and the vertical shift. So for example, when I have the cosine of 3x, there is only b here, there is nothing else. B changes the period. The new period will be 2 pi divided by b. So 2 pi thirds. This b here, so b here is equal to 3. This b here is equal to 1/3. So x divided by 3 is the same with 1/3 x. This period will be 2 pi divided by 1/3. When I divide by a fraction, I multiply by the reciprocal, which is 6 pi. So if I graph, for example, 2 cycles of this function, they give me a equal to -2, and they give me b equal to 3. And the c is 0, and the d is 0. That means I don't have a horizontal shift. I don't have c divided by b. That's a 0. So I start at 0. Horizontal shift is equal to 0. I also don't have a vertical shift. So the midline doesn't change. The midline continues to be y equal to 0. I'm graphing a sine function. So I'm graphing a wave that looks like this, starting at the midline. But a is negative, means that this graph will be reflected with respect to the x-axis. So actually my graph for my sine function will look like this. So I will start at 0, 0. I'm going to go 1 cycle, and I'm going to go 1 more cycle. They are asking me to graph 2 cycles. So the question is, what is the amplitude? The amplitude is equal to absolute of -2, which is 2. And that means that this graph will actually stretch. Let me move it. There you go. So it will be stretched. It will be stretched in a way that instead of having an amplitude of 1, it will now have an amplitude of 2. The midline continues to be y equal to 0. So I actually know the y coordinates of these 5 points. So the first point has a 0 horizontal shift and the 0 for a y. This point has a 0 for a y. This point has a 0 for a y. This point has a 2 for a y. This point has a -2 for a y. And what I don't know is the x coordinates. The x coordinates depend on the period. Now the period is 2 pi divided by 3, and I need to split that into 4 pieces. So I need period divided by 4, which is 2 pi divided by 3 times 4 here in the denominator. So this is 2 pi 12ths or pi 6. So every increment will be pi 6. So from this 0 to from this x value to the next x value, the increment will be pi 6. So 0 plus pi 6. From this x value to this x value, the increment will be another pi 6. So that will be 2 pi 6. From this to the next point, the increment will be another pi 6. So that will be 3 pi 6. From here to the next point, it will be 4 pi 6. I am adding pi 6. So I had 0, then I added another pi 6, then I added another pi 6, then I added another pi 6, and then I added another pi 6. And these were the 5 points based on the horizontal shift. Now, let's find the horizontal shift for this one. It's also called the phase shift. My b is equal to 1. This is minus c. Minus c is negative pi, so c is equal to pi. Therefore, the phase shift or horizontal shift will be c divided by b, which is pi. So my graph is not going to start at 0, x equal to 0. It will start at x equal to pi. Now here my b is equal to 1. The negative c is pi over 3. Therefore, the c is negative pi over 3. And the phase shift or horizontal shift will be negative pi over 3, which is the c divided by b, which is 1. So negative pi over 3. Here I have a d equal to negative 1. Therefore, my midline is y equal to negative 1. Here I have a d equal to negative 1/2. Therefore, my midline is y equal to negative 1/2. Remember that the midline is a line, so I'm looking for the equation of a line. Let's do a little more complicated. So here I have a equal to 1. That means no vertical scale or reflection. I have b equal to 1, no horizontal scale or reflection. I have c equal to positive pi quarters because minus c is part of the formula, the negative sign, and I have d equal to 1. So I have an amplitude of 1. I have a phase shift of c divided by b, which is pi quarters. I have a period of 2 pi divided by b, which is 1. So 2 pi. And that means that my quarters will be pi over 2 because it's 2 pi divided by 4. And then I have a midline of y equal to 1. This is a sine function. So this is my midline, y equal to 1. And this is the graph of the sine function. It starts at the phase shift of pi quarters. So the first point is pi quarters for x and y equal to 1. The amplitude is 1, so this y will equal to 2. I'm going to be back to y equal to 1, and this y will equal to 0, and then back to y equals to 1. So the question is, what are the x values? I know this is pi quarters, but what are the other x values? So every increment is pi over 2. And therefore, I'm going to do that math somewhere. So I'm starting at pi quarters. I can do it here. Plus pi over 2 will be, pi over 2 is 2 pi quarters. So pi quarters plus 2 pi quarters will be 3 pi quarters. So first is pi quarters, then it's 3 pi quarters. Then I'm going to add another pi over 2, which is another 2 pi quarters. I will get to 5 pi quarters. That's my third point. Then I'm going to add another 2 pi quarters. I'm going to get to 7 pi quarters. That's the fourth point. And then I'm going to add another 2 pi quarters, and I'm going to get to 9 pi quarters. I have all the desired points, so I'm ready to graph. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 pi quarters. So that's 1 pi quarter, 2, 3 pi quarters, 4, 5 pi quarters, 6, 7 pi quarters, 8, 9 pi quarters. And my midline is y equal to 1. And if you remember, this is the graph of my sine function on the left, right here. And I want to move this up on my graphing paper. So pi quarters with the midline, 3 pi quarters with the top, pi quarters with the midline, 7 pi quarters with the bottom, which is y equal to 0, and 9 pi quarters with y equal to 1. This is my graph. And I can now write the coordinates of the 5 critical points. Pi quarters with 1, that's the midline. 3 pi quarters with 2, that's the top. 5 pi quarters with 1, that's the midline. 7 pi quarters with 0, that was the lowest point. 9 pi quarters with 1. And this is only one cycle of the graph. Obviously, there are more cycles that I'm not graphing here. Let's do this one. This has an A equal to 1. It has a B equal to 1. It has a C equal to negative pi over 2. And it has a D equal to negative 1/2. So again, remember to reference your packet. We want to say, what's the horizontal shift? C divided by B. What's the period? 2 pi divided by B. What's the amplitude? Absolute of A. What's the midline? Y equal to D. Then find the coordinates of the 5 points. So A equals to 1 means the amplitude is equal to 1. B equals to 1 means that there is no vertical stretch, so the period is 2 pi divided by 1, which is 2 pi. That means to me that the quarters of the period will be pi over 2. 2 pi divided by 4. The C is negative pi over 2, so the horizontal shift is C divided by B, which is negative pi over 2 divided by 1. And the midline is the vertical shift y equals to negative 1/2. This is a cosine function. This is the midline, y equals to negative 1/2. And the cosine graph goes like this. The amplitude is 1. So this part is negative 1/2 plus 1. This part is negative 1/2 minus 1. And then I have 5 critical points. And I start at the horizontal shift of negative pi over 2. And I want to find all the others. And every increment is plus pi halves. So plus pi halves, plus pi halves, plus pi halves, in plus pi halves. So I'm going to start at negative pi over 2. This is my first point. I'm gonna add pi halves, that will get me to 0. I'm gonna add pi halves, that will get me to pi halves. I'm gonna add pi halves, that will get me to 2 pi halves, or pi. And I'm gonna add pi halves, and that will get me to 3 pi halves. These are my 5 points. So, I'm started at negative pi over 2, 0, pi over 2, 2 pi halves, 3 pi halves. My midline is y equal to negative 1/2. And I'm starting here at the top. Then I go to the midline, then I go to the bottom, then I go to the midline, then I go to the top. And this is my 1 cycle. What are the coordinates? At negative pi halves, my y coordinate is negative 1/2 plus 1, which is 1/2. At 0, my y coordinate is the midline. At pi halves, my y coordinate is the minimum, negative 1/2 minus 1. At 2 pi halves, my y coordinate is the midline. At 3 pi halves, my y coordinate is the maximum. These are the 5 critical points. So let's put everything together now. We will have A and B and C. In this example, the function they gave me looks like this category. So I'm looking for A, B, E, and D. So the A is over here, the number 2. That makes the amplitude equal to 2. The B is 2. That makes the period equal to 2 pi divided by 2, which is pi. And obviously, the quarters of the period will be pi quarters that I will need for the x-coordinates of my critical points. This is minus e. So the e here is negative pi over 4. And that says that the phase shift or horizontal shift is actually equal to e. So it is negative pi over 4. That will be my horizontal shift. The next thing is that the y, the midline, d is equal to -1, and therefore my midline will be y equal to -1. This is a sine function. It has a positive a, so it's going to start at the midline, and it's going to go like that. Y equal to -1. And the amplitude is 2, so I'm going up to -1 plus 2, and I'm going down to -1 minus 2. And then I start here at the phase shift, which is negative pi over 4, and I add quarters of the period to find the other 5 critical points. So plus pi quarters will get me to a 0, plus pi quarters will get me to a pi quarters, plus pi quarters will get me to 2 pi quarters, and plus pi quarters will get me to 3 pi quarters. So I need those values. So negative pi quarters, 0, pi quarters, 2 pi quarters, or pi halves, 3 pi quarters. The midline is y equal to -1 over here. The highest y is 1 over here, 1. The lowest y is -3 over here. So I'm going to start at negative pi quarters. I'm going to go to the highest point, back to the midline, to the lowest point, back to the midline. I need the coordinates of those points. So I have a negative pi quarters with the midline, -1. I have 0 with the highest point, which is 1. I have pi quarters with the midline, which is -1. I have 2 pi quarters or pi halves with the lowest point, -3, and I have 3 pi quarters with the midline, -1. Let's stop this video here because it's becoming a little too long, and we will do a third part for this to finish the problems with the transformations of sine and cosine function, and then do a backward problem. What happens when we have the graph and we want to find the transformation?